Well, good day, everybody, and thank you for tapping into Well Power's first webinar. I'd like to introduce myself. My name is Dan, president of the company, and we have Ed Barton, who's a consulting to the company on. What I'd like to do is just move the presentation, and that if you have any questions, we can answer them at the end, or if you like, you can email questions in. Okay, so we're ready to go. Rana? Hello, Rana? Can you hear me?
Yeah, we're ready to go.
Okay, can you hear me, Rana?
Yes, I can.
Rana, I'm just checking. Can you hear me?
Yes, Dan, I can hear you.
Okay, great. Okay, so what I'd like to do is just go over the overview of the company and what company called ME Resource Corp, and they've been developing. And now what we've done is we've licensed it through Well Power for the U.S. And the first state that we've licensed the technology for is the state of Texas. We are targeting the oil and gas and industry, and the areas that we're looking at here in what we're targeting are the shut-in gas, flared gas, and hard to get to or stranded gas. We feel that there's a high demand in the marketplace for this technology, and we'll explain that as we go through the presentation. The research and development team that we have behind us is very experienced in the field of catalysis, and what we've actually done is we've taken technology that's being used in the past, and what we've done now is innovated it with today's technologies. Currently, we are preparing for commercialization. So we'll address this as we go through the presentation. Okay, next. Okay, so Well Power licensed the technology, and we announced this on January the 22nd. It's through our 8K filing. So if you wanted some more background information, it's available there, or if you like, we can have it sent to you. Our solutions, again, are to flared gas. There's a lot of legislation coming through now in a number of states where they want to reduce the amount of flaring that's going on. Shut-in gas, and that could be gas that's unprofitable or whatever, and then stranded gas. What's unique about the solution that we're offering is that it's a mobile unit, scalable, and easy to get into difficult areas. We've initially licensed the technology for the state of Texas, but we do have a right of first refusal across all the states. And as we say here, we are in discussions to add more states to our portfolio, and as we conclude those discussions, we will announce those. The other thing that we've done that is unique is that we don't have a set in concrete type of rollouts on the technology. So what we're trying to do is allow ourselves to remain open to different types of business alliances, joint ventures, acquisitions potentially. So we're trying to leave this open so that we can enter into joint ventures or whatever that benefit Well Power and the shareholders in the strongest way possible. And the technology is protected by licenses by patents. Next. Okay, so as I say, we're targeting the oil and gas industry, and what we're looking to do is help optimize their production through the reduction of waste and emissions. We feel that what we have in the size that we have, we're able to move into and build basically our own niche market in this area. We're not going after huge producing fields or anything like that. We're going into the more smaller type fields that are more prolific than there are, the 10 million, 20, 50, 100 million a day producing fields. So we feel that our technology and its proprietary solutions are flexible, scalable, modular is very important, easy integration onto the site, cost-effective, and profitable. And these are just some of the articles you'll see out there right now about what's going on with the flaring, the way that some states right now have so much flared gas going on that they're lighting up as much as say a city of Chicago. It's interesting. So, okay, next slide. Okay, and now here's just some of the activity that's going on in the now where we have our first license. So there is a lot of opportunity for well power in this area, and the regulation of Texas, which regulates the oil and gas industry, they are now going through. And if you want to flip to the next slide, Rana, please. Flip to the So this is starting to occur in a lot of the states, and this is another opportunity that is also opening up for well power with the technology is government legislation. So you've got a lot of opportunity just fundamentally out there in the marketplace now, and now you have some of the states coming through with flaring regulations and wanting to reduce that. So again, an area that we can capitalize on. Next slide, Rana. Okay, so here is the management team. Another thing that we're really trying to do with well power right now is keep our overhead costs down as low as possible. So what you'll see at the management level is Christian Nago and then myself, and running the company right now. But we do have a very strong advisory board behind us. And Brad Barton is on the line, and he will take the presentation from here. But as you can see, we do have very strong depth to the management of well power that'll help us to take it further. And then as we begin to grow and need more personnel, we can bring them on stream. But we want to, at this point, keep the operations and the overhead of the company as low as we possibly can. So, Brad, if you want to take it from there.
Thank you, Dan. Rana, can you flip to the next slide, please? Okay, effectively what the well power solution is to find undervalued gas. And that's gas that's stranded, shut in, flared, wasted, vented, using our technology in the middle, which I'll explain further. And then we can create value end products. So we've got engineered fuels, which we can tailor to the specific needs of the site. We can create electrical power, heat. We're reducing greenhouse gas emissions, so we get credits for that. We can make ammonia if we want, and then there's other end products depending on the specifics of the site. Okay, Rana, next slide, please. Okay, the advantages of our micro-refinery unit compared to other people's technology is we are energy efficient. The reaction is actually exothermic. No energy has to be added in. We get a high yield. So we can create 32, 38 API oil. We can create diesel. We can create invert mud base frac oil. Like I said, it just really depends on the needs of the individual site. It's a single vessel, which keeps the cost down and minimizes the amount of control and process we need to work with things. It also helps with safety, and we can do units as small as 100 MCF a day and up to 500 MCF a day. If we need more than that, what we do is we'll use 2 or 3 units in parallel to create. So if we needed 1 million a day of capacity, we would put 2 units in parallel. Next slide, please, Rana. Okay, I'm going to walk through the steps here, and then the next slide I'll talk about how we can modify these slides, these boxes, to fit the individual process. So box 1 is just an inlet separator. We need to take the free liquids out of the gas. So you've got a mixture of oil and gas coming in. Oil and water go into the tank and the gas goes through the process. Box 2 is preconditioning the gas. If there's a little bit of H2S in the gas, or if there's still some really some free water in there, we'll need to have an H2S scrubber or another desiccant dryer type unit. Box 3 is compression. Now our unit operates at 30 bars and 900 Fahrenheit, so we need the the compression here. One of those compressors is air, and one of those is the natural gas. And then we go into our box 4. Now our box 4 is the actual patented technology. All the other boxes on here are off-the-shelf, standardized oil patch things that anybody familiar with oil patch operations knows how to operate. Box 4, that reactor vessel, is a 2-stage reactor. The first reaction is a Pox reaction, and the second one is a Fischer-Tropsch. In between the 2 reactions, we need to drop the temperature, so we have a heat exchanger. That heat exchanger can be used to create electricity. It can be used to preheat frac water. In Canada, it can be used to prevent freezing at water tanks. It really just depends on the situation and where the person is. Box 5 is just a back pressure regulator valve that will also spew off heat and pressure, which we can use for different processes depending on the situation. And then box 6 is a separator vessel again. We have some unreacted gas which we can use to either power a generator or power our compression. And then there's some tanks that may or may not exist on site. Okay, next slide, please, Rana. Okay, a lot of times in the people bring out new technology, and it is very, very, very rigid, and it only fits in very specific cases. Our technology, the way it's designed, we have our reaction vessel. That was the box 4 on the previous slide. Now, if we can go back there for a second, Rana. So we have the box 4. That is what our patents are around. If you have a site that already has an inlet separator and already has storage tanks, we don't need to bring those out. If you have a site that already has compression, we don't need to bring those out. Now this is very important because this means we can modify the vessel or the process skid to match the individual site's needs. Now this also drives how the economics work because we can change the business alliance based on what kind of skid we're providing. Okay, thank you. Next, go forward there, Rana. Okay, so basically we can modify our reaction to change the end products depending on the need. If you're in a remote location and need diesel, we can make you diesel. If you need frac oil, we can make you frac oil. If you just want to sell high API crude that just straight down the pipeline, we can create that as well. It really depends on the situation. Okay, next slide. Now there's two ways to view the economics of this unit. One is an alternative to flaring when producing oil wells, and the other one is selling liquid hydrocarbons versus natural gas. So let's look at the first way, alternative to flaring. That's the next slide. Okay, so the alternative to flaring, the considerations revolve around flaring regulations, relative capital cost to MRU to gas facilities, electrical generation, and both of those are a function of existing infrastructure, and timing considerations. With Texas saying you can only flare your wells for 10 days, you have to leave your well shut in until you have the opportunity to bring pipe there. So now I've got a sample of the economics on the next page. Please move forward there, Rana. So what this is an assumption of, and this is an analyst up in Canada did it for the ME company, so I just borrowed the slide, but it's illustrative of the impact of the timing of bringing a well on production. If you bring it on production in 3 months, you have your MPV10 of 8120. If you bring it on immediately, you have an MPV of 8346, which is a 13% change in MPV10, which is significant. Now, the only way you can bring it on immediately is either to put the pipe in the ground before you know what you have, or to take one of our units out there and rent it for 3 months, and then so that is an opportunity to bring your wells on quicker. Next slide, please. The other way to look at it is selling liquid hydrocarbon. Now, we have recently been approached by various producers and groups in the States on this one because there's a bunch of undervalued gas in the States. And as you can see, if you have 100 MCF of gas versus 10 barrels of oil, that's a revenue of $300 a day versus $1,000. Now, that is just the revenue side, and you have to consider capital costs and operating costs. But there's where our flexibility in our skid design and our mobility really come into play, that we can change and modify not only the skid, the products, but also the business arrangement. Okay, next slide, please. So you can see here the relative value of the different products that can be generated on the right-hand side there. A reduction in flaring is $30,000 a year in greenhouse gas credits. Production of engineered fuels, that's $450,000 a year. Power generation, if you're selling it at 40 cents a kilowatt hour, is $125,000. And water production, and in some places, water production is worth way more than 50 cents a barrel. If water is short, then water used in fracking is a big issue, and I do believe that's a huge issue in Texas. So the total annual economic benefit is in the $620,000 range for a 100 MCF unit, for one 100 MCF unit. Okay, proceed. So how is the potential in the U.S.? So right now in the United States, and this data comes from the World Bank, there's 7.1 billion meters cubed a year flared in the United States. Now, I couldn't get my head around that number, so I just started putting in the chart at the bottom has the conversion numbers and works through the math for you. But basically, there's currently estimated 70,000 barrels a day that could be, that's flared gas that could become engineered oil. So that is the size, current potential size of the market. Okay, next slide, please. So market opportunity worldwide, it's huge. There's all sorts of stranded gas that's being flared. You can read it and look this up for yourself. It's World Bank website. Next page, please. And here is some of that information monetized. You can see the USA is 7.1, as I've already said, and you can look at the global flaring level as 140,000 or 140 at the very bottom there. Okay, next slide, please. Okay, Dan, do you want to do the summary?
Sure. And then we'll open it up to questions. So, Rana, will they be able to verbally ask a question, or do they have to email it in?
They'll have to email it in, and I'll put the email on the side comment box there. It's info@wellpowerinc.com, but I'll also put it there so they can email in their questions.
Okay, great. So yeah, just in summary then, we do have strong patents on the technology, and so we're really excited about when we can start getting these out into the field. And I guess just to say that the research and development team have been working hard and diligently on behalf of, I guess, WellPower and ME Resource Corp to get ready to build the first couple of commercial units. I don't know, Brad, did you want to, are we able to give a bit of a discussion on that or not?
No, I don't think we're at a point to discuss the patent technologies at this point.
Okay. 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 So the fact that we're able to move the units around really will give WellPower very strong competitive advantage. Some of the other companies out there that are also exploring technology are much larger scale and be building it as sort of fixed. And we feel that if we can one site to another site to another, and at the same time scale up, that gives us more advantage in the marketplace. It does improve the well economics, and as Brad pointed out, what we're looking at converting is 100 MCF gas to up to 10 barrels of oil, liquids or diesel. The peak number at peak efficiency, 100 MCF would convert to 16 barrels. So being at 10 barrels is a very strong position. Do have the license in place for Texas, and again we have discussions ongoing, and there is other regions that we are in discussion on. The types of relationships that we're working are strategic alliances so that everybody benefits, and we do have a lot of interest in the financial community as well in financing WellPower on a go-forward basis. So with that, I would like to thank everybody for their interest and tapping in, and